joining us, everybody, as well. We're looking at obviously surfacing your Contensis content via a search. I'm Neil Flatley. Had the good fortune of working with some of you before, but for those I haven't, I'm a solutions architect with professional services, focused mainly on back-end implementations. Previously specialized in system support and then retail integrations using service bus technologies. More recently then writing and maintaining packages published on NPM for both Zengenti and the open source. So that's me. The key takeaways from today's webinar is you'll learn how to implement the full featured search on your React-based website from data held in Contensis. We'll discuss advantages of configuring your search, help identify what's needed in your search based on the business logic and requirements that you have, and we'll also see real-time examples of your search being configured. So, why did we create a search package? Well, it's a few years, cast your mind back a few years, we were basically starting out with JavaScript and React, and we'd also hit the ground running with some real projects. With those real projects, we had the chance to iterate and refine with each iteration, and we began to understand the technology more. And then as we did that, we were gaining confidence. So there was a time where we were also delivering what we refer to as our base package, but is now called Contensis React Base. We'd also delivered a number of bespoke search solutions for clients. There must have been around a dozen. Me personally delivered around 5 search projects back to back, and we quickly realized that everybody is different. Everybody's requirements are different. Everybody's content is unique to them. However, we did identify that there were some similarities in the implementation. And another bunch of good reasons to use a search package is it's simpler, first of all. You're not starting with a blank page. You've actually got tried and tested approaches to actually fall back on to give you the functionality. Gives better visibility of your business logic and the way the search is put together. We once hired a client of ours had to hire a developer for a day and a half once just to tell them what they had in their search, for example. So it's always good to have that visibility on the forefront. It's always better quality as well because it's taken a more common approach. It's optimized for use with Contensis and the latest versions. It's reusable with the functionality that it provides and the components that we write, the mappers that we write as well to translate those raw API responses into stuff our application can use. We'll get better consistency. So for example, you shouldn't be in a situation as why does my course page work completely different to my blog listing page? And with that consistency, there should be less bugs for people to find and less debugging for developers to do. With that, you have better support as well. We'll have documentation, we'll be agile to change. If Contensis, for example, suddenly has a whole load of new search features, you'll be eligible for free upgrades. We'd have coming in the pipeline is TypeScript support to make things easier to implement further. There's overall less barriers of entry. For example, you don't need a dedicated back-end developer to implement this kind of thing. You could simply hand this to anyone who's comfortable putting React components together, and they should be able to handle what's going on there and be able to do the implementation themselves. With all of that, then we should have a quicker turnaround for projects. It should offer us better value overall. And with the simplicity, it means we can then spend more time to focus on the real challenges in our projects. So the things that we require to create a search with Contensis is a React application running currently with Contensis React Base. Essentially, that is just a way of creating applications with Contensis and React. It's kind of like a massive leg up, if you like, to get started with Contensis and React. We'll also need some components to go with that. We'll need a configuration, as I've spoken about. We'll need some mappers. We'll go into that in a minute. We'll need some routes for our application to respond on. And we'll need a trigger to trigger the search. So as I suggested earlier, Contensis React Base. If any of you here have started with Contensis and React, as many of you probably have, you'll likely already have this to work with, and you should be used to working in it. If not, Contensis React Base is what we refer to internally as our base package, and it handles all of the sort of things that make your website work with Contensis. So you can point your application to a specific route, it should query it from site view, and it should then return an entry for you to then render out in whatever web page format that we wish to render. Inside that Contensis React base as well, we'll also need to import what we call reducers and sagas from our search sub package. What that will do is the reducer will keep a place for us in the application store, and it will also load our configuration into that store as well. The sagas then will actually enable the application to listen to the search actions that we're performing and then react appropriately to those actions. The components then, we'll need a whole plethora of components to implement a full featured search, and these are just the main ones. First of all, you're going to need a page to render your search in. You'll need a search input box for your users to type the search terms into. We'll need results. These are often cards or tiles. We'll need some paging features, however that appears. Optionally, then you can expand the search with search filters. We can have additional facets for a multifaceted search. We can have facet switches. And then finally, we'll have this container component. So React developers should already be familiar with this concept. A container component is essentially a component enhancer or injector where we will fetch things from our Redux state, for example, and add things to our components to render them as some components later down the line. So if we just quickly show you what we're referring to, this is what we're referring to when we mean a page. It's just a page. We also have a search input box that will live inside our sort of layout that's inside our page that dictates the layout and look and feel of the page. That should then redirect us to our search results there. You can see the search results are highlighted. These are, as I say, cards or tiles or however, whatever sort of terminology we use in the application. We'll have our facet switch there along the top, so we can change like the view or the facet or whatever of the search, create like a concentrated view of a specific subset of your site data. Then there's the filters. They can be rendered anywhere you need them, but yeah, essentially we'll handle the fetching of the items to display in the filters. These are quite often content type entries, and the application then will perform a new search then when we change our selection to filter our results by a specific criteria. Then there's pagination. So this one takes the form of a load more button at the bottom, which will load the next page of results, append it to the end. Another common approach is to have your sort of classic pagination buttons where you've got your first page, last page, next page, previous page, and all the pages in the middle, kind of affair. And then the other approach would be to have like infinite scrolling, where once your user scrolls to a certain point on the screen, it will automatically trigger to fetch the next page of search results. So away from components onto configuration, this is essentially the shape of the search. It's what it's going to look like and how it's all laid out and faceted and divided. Inside each of these facets, it will specify the content that we're looking for and how much of that we need to return. We'll then specify ways to further filter the results. And then there are other things we can put in here that controls other fine-grained behavioral stuff which we'll see an example of that shortly. Mappers, if you're unfamiliar with this concept, we use the term mappers, but it can also mean transformation, data transformation. Essentially, it means translating the raw content type fields in our API calls into something that our application can use. So in this case, it's props to fit our components. We'll look at that in detail in a minute. And then the optional, we can add some additional mappers, basically, which can control some custom behavior when we retrieve filter items. We can create a prop called results info that can be anything we want, that can display meaningful messages, other information about the search retrieved from the state. For example, return showing 1 to 10 of 3,000 results, and you can put things like how long the search took to take, or if no results are returned, you could potentially offer alternative things to the user to look for. And then another mapper that we have is to handle sort of custom URL formats. Basically, you can define the exact URL structure that when we take a search action, what the URL will look like after that search action has been performed. But that's more for sort of like heavier customization stuff. The really important one that we need for today is to translate our raw content type fields from the API responses. So we'll look at that in detail in a sec. Next thing we need is routes in our application, and routes in a Contensis React-based application will either take the form of a static route or a content type mapping. A static route is like a sort of any JavaScript developer should be familiar with this concept. It's basically a permanent fixture in the site that will never change. So, for example, if your search is at /search on your site, then you may as well define that as a static route rather than us have to query the CMS and say, what's at this route? Oh, it's a search page. Let's render a search page. We may as well just use a static route and have it cut out that extra step, really. However, a static route is required if you wish to use route-based search parameters. So that's kind of like where I was saying that we want to dictate the actual structure of the URL that actually comes out when we do things in the search, so it can fit this sort of static route with the layout of the search parameters. We'll also, beg your pardon, no, we'll also, another approach is to have content type mappings. So essentially this is a list of content types in your React application, and when a route is retrieved with an entry of that content type, it will know which component to render, and then that component should understand all of the data that you've told it to get from that specific content type entry. Another use case for this content type mapping is quite an advanced one, but if you wish for your editors to set certain search parameters in the entry data, so you may wish to display like an inline course listing widget, for example, and you may wish to allow your editors to say, well, I only need to show undergraduate courses in this particular list of search results. So you could have them set that in the entry data, and then we could have some logic then to control that as a parameter to feed into the search. So the search is pre-filtered. The final thing we need to make the search work is a trigger. So what we need to feed to the trigger is all the runtime parameters that we need. So things that we've injected into the URL, stuff that will allow us to return the search to exactly the same state as where we left it, really. This could be useful just so that you've got like a static link to give to someone that shows exactly what you're looking at. And you can always return to that point in time as well. So the runtime parameters could appear in the query string, they could appear as part of the static route, or as I discussed just then, we could be resolved from entry data that was in the route that we've landed on. And then the trigger for the search itself would either be, depending on how we need it to behave, would be a Redux Saga call directly from our routing event. Or if we don't need it to work at that level, we need it to kind of work in line at a component level, we can use a React hook that underneath the covers calls a dispatch method to dispatch a specific search trigger action. So that's everything that we need to get up and running with a search. So let's get right to it. Let's have a look at some code and let's see if we can implement a live search. So I'll quickly just recap on the things that we've got in this application. We've got a static route already set up, and that's set up to look at a search route. We've got this sort of funky looking syntax, and this is where I was mentioning about route-based parameters. So what this means is it's an optional parameter, and it will, if something exists in the URL at that part, it will then be fed to the application as a parameter called facet. That will then obviously load our search page, which has all our layout stuff in there. I can move on to configuration then, which is a shape of our search. So what we're trying to do is define a faceted search. So we've got an object called facets. Here is our all search results facet. We specify the title in there, and we can give it some query parameters. Those query parameters, because it's all search results, it's generally searching over all the content in our site. So we've got blog content type, content page, landing page, plants and pots going in there. We're going to fetch 10 results for each page, and we've got this sort of behavioral tweak going on here where we're telling it to use load more paging as opposed to classic pagination. And then as an extra sweetener, I've got a little bit of TypeScript going on here. So this will help me when I'm sort of trying to type my config out. It will lead me and guide me and hopefully tell me if I've done something wrong with that. We've also got mappers. So I've got this concept of a base mapping, and I've got my props going in. So these are for my search results. If I can wind this back a little bit, actually, we've got all these different kinds of mappers actually that we're passing to the search. And we've got one for our search results, which is going into this function here. And what this will do is basically map the results that are returned in our API response to give us normalized props that our components can use. So we've got a type prop, which is basically a generic card. So this is just saying that it's non-specific at the moment. Our title prop is fetched from entry title field, so that's something common across all content types. That's pretty generic as well. We've got this concept where of a text field, but all of the content types have a different name of this field. But because we've got this mapping layer in place, and this funky little bit of syntax here will allow us to look at any of these fields in the returned entry. So if one of these in this order appears in the result, it will map that as our text prop. We've got our sys.uri field, very Contensis. We've got our image URI field, again, asset.sys.uri. We should not need to write this, and this should not appear in our components because we've already normalized it to a prop called image URI. And then it's also got a fallback image. If an image doesn't resolve at that path, it will fall back to this fallback image. And then we've got the same type of thing going on with the image alt text, where we're searching in a number of places to try and find some alt text for the image. If it's not in the proper place, it will look in the caption, then it will look for the asset title, just to ensure that we've always got alt text. So then we've got components. Essentially, we've got all of those components I mentioned earlier, but then we have this container component. The container component will already be encapsulated with a page and a layout. And then we've got this search filters component here, search input, search cards, more filters, and our pagination. So again, it looks very Reacty. It's kind of there already for us. So what we can do then is have a look at what this looks like. I've actually started the server up already to save the time. So I can Alt Tab. Here it is. This is the website that we're working on today. This is Leaf, and Leaf is actually a fictional client. we were looking to create a demonstration site to have all of the sort of features in there that we can use for a number of things. And Leaf is our client that we're created that site for. So they essentially just sell plants and pots for your home. We've got a home page here just because it looks nice and it looks like a website. But we've also got this search page here that's already prepared and sort of has all the components in the right place. It's kind of hard coded at the moment, so we can see it's all hooked up to like alert boxes so that we can just see some stuff happening. Cool. So to get on with the implementation, we are going to focus mainly on this search container. This is our component enhancer or props injector. And what we've got going on here is a React component. We're actually using TypeScript on this one. So what this does is it gives us some extra stuff that we can use to kind of help and prompt us along the way. If you were working in plain JavaScript, your component would look a little bit like that. Hopefully that's a little bit more familiar. But obviously we've got the TypeScript stuff available, so we may as well use it. What we've got here is our own props, which is defined, and we've only got class name being passed in as a prop, which is there. And then we've got these additional props called search props. Now these are imported from the search package. And if we can have a look at these by pressing F12, we can see that we've got all of these props that will be injected, and these props will be available to us to use. So to save us a little bit more time today, I've already got these props here. So what I can do now is just go ahead and implement this, and we'll see exactly if we can make this come to life and if we can make this functional with the configuration that we've got in our configuration here. So let's go through. So what we're going to do is replace all of these props here with real props, all these alert boxes. So we've got a clear filters prop for our search filters. Actually, I've missed a stage, beg your pardon. It's going, what the hell are you? What we need to do is on our search container, we're going to enhance this component with some extra props. This comes from a higher order component called with search. And what we do with that is we wrap our export with the higher order component. The higher order component requires an argument, which is our mappers that we're defining. So I'll put that in there. And then we'll also make sure we're wrapping our export for our search container. And then if I go back to where I was, we can see now clear filters here is recognized and it's happy. We can also use the TypeScript typing to see if we have any arguments that we need to supply, but we don't need to supply any for that one. We've got a current facet prop, which I can see that we've got imported above. So I can put that in. Then our search filters component needs to know what filters we're putting in there. But this is kind of a little bit funky because we've got mobile and desktop things in the same component. So I'm going to handle that here. What we're essentially saying, if it is in desktop mode, let's see if I can get this right. If it is in desktop mode, we want to display just facets at the top there. But if it's in mobile, if it's switched, the layout has shifted, we will want facets and filters. Cool. Hope that's right. If it isn't, then we won't worry too much. Update the current facet now. This is obviously taking the job of the facet switcher, so we can replace that with one of our props that we have available. This one needs an argument called facet, and that facet is a string, so that'll be the next facet to update to. We'll feed that in there, and then we've got an update selected filters action prop as well. This will be the handler for when the filter selections have changed. It requires, facet, wrong one. It requires a couple of arguments. I think the first one will be the filter that we're applying, and then the actual value of that the actual value that we're applying to that filter. We've then got our search input component. So we can replace that with a real prop then that we've received from our enhancer. And then we've also got this action prop as well, date search term. We've got this text about the results we have found. Okay, so what we've got is this results info prop that I mentioned earlier, where we can sort of code it to be anything we want to tell us some stuff about the search. So we've got one called results info, results text. Then this is the meaty bit now. We've got our search result card. So what we need to do is iterate over our search results and then render out each search result as a card component. So let's see if we can do that here. So I've got a prop called results, and that is an array of search card props. Let's have a look at search card props. That's fed into search props there, and search card props will look a little bit like that. So we will map over our array of search results, and then for each result in there, we will render a search card with the props. So looks okay. So let's change that then to some real props. So as well as a result, we're going to have an index for each result in the array. We'll put the index there. We can then make the title as what our prop that we map. So that would be result.title. We've got an image URI, which is result.image URI. I think there's no prizes for guessing the next one. Result.image alt. We've got this price here. We haven't seen that one yet. Do we even have that one? We do. Okay, so let's map that one in anyway. And then we've got a text, a description of the search result. So I presume that's result.text. The type of result it will be, result.type, and then it would be the actual destination, the actual place we send the user to when they click on the search result. So result.uri. Okay, so hopefully that's all good and implemented correctly. We'll quickly scoot on to do this one here now. So this is an extra instance of the search filters component, and this is particularly just for desktop mode, so it can handle a different location in the DOM for when we do that layout shift. It's more of a sort of design consideration rather than something that we actually need to make this work today, but that's fine. I can quickly do this. We've got some filters, so we got our filters from our prop. Then we want the update current facet again. And then update selected filters. Final component we have here is, I've got a typo, fix that. Final component is our pagination component. So this is our load more button. The only thing we need to implement on here to get this to work is this action prop here. So this is called update page index, and the next page index will be current page index +1. So this is using all the props that has been supplied to us by this with search component enhancer or higher order component. It could appear potentially as a React hook as well, and it could return the similar sort of props or similar sort of variables for us to use. But what's happening now is hopefully this will live reload for us. I've got another error. Then if we also get rid of all these extra red things out of here, just to make sure it all works happily and hot reloads all on its own. Works as a search. But where would we go with this now? We want to expand this some. Well, to expand it some more, we could add some more facets up at the top. And the other thing we've got is that the filters are all looking rather plain. I'm very sorry, I've lost my slides. I'm just going to have to quickly grab them. Do. And yeah, let's make this a little bit more. Let's enhance it some. So before that huge car crash earlier, we were doing rather well, and it was quite simple. So let's go back to our config anyway. This is our nice simple config. Hopefully this is something that's going to work for us. So what we can do is add another facet to it, and it can be a blog facet. Facet will need a title, and that would be blogs. And then a facet also needs to know some query parameters. So we can put those in, and the query parameters generally are content types. And the primary one is no surprise that it'd be blog content types. We have to just copy a couple of bits from here just to make it work the same way as the all facet. And then there's one extra thing that we haven't got there, which we could potentially add into here, is some filters. So we've got our blog filters in a separate file, and a blog filter, or a filter rather, would just tell us where we're getting our filter items from. So we've got a category content type, and then in our blogs as well, the fields that will be used to filter the results by will be the category.sys.id field in the blog. So when any of these values change, that's what it will be filtered by. We can also hard code filter items if we need to, or in this case, we're letting it fetch it from a content type. Similarly, we can get authors from our person content type, and it will be filtered by our author field in there. So let's save that, and let's have a look. And we've now got a blogs facet. But let's not just go there. Let's go a little bit further. If we can look in our mappers, you can see at the bottom here now, we've got this sort of named object with a named key of a default, which is assigned to our base mapping. The reason for this is that we can expand it to suit, we can use discrete mappings for different content types, because a blog is going to have different fields to a plant and a pot. And in this scenario, a plant and a pot is actually a product. So they're going to have sort of very different things going on in them. So what we can do is add these extra mappings back in. And I've also got some stuff commented out here ready as well. So we've got products, and a product has a price. So we saw a price earlier. It has a product type. It has a few extra little things that make it a product, as does a blog. It has a publish date on it, and that's slightly different again. So let's see what happens when we've added those extra mappers to the results. And here we go. You can see now we've got the products are all nicely highlighted. They've got their product image, they've got their price range on them. They're looking a bit more producty. And then the blogs have got a little bit more going on as well. I'm not sure what that is, but yeah, we've not seen that one before, but let's not worry too much. So you can see it all works, and it displays the correct format of card for what it is we're looking to return as well. We just check these filters as well. We can look for care advice blogs that for our dog, and then we can also filter by author as well, and that will update the URL. We'll also get some behavioral stuff in here to display some proper messaging when there's no results returned. But we can also use the back button, which is not something that you can't really take for granted in JavaScript either. But yeah, there's our search. So if I go back to my presentation and skip. So what can we do with this further now after this? Well, we can do some tuning. We can actually specify fields in our configuration. And what that will do is reduce the amount of data coming back from the API and the responses. So the theory is it makes things quicker and it's less data to download to display your search results. We can add featured search results quite easily, which gives us a new array in our props called featured results. And that's generally for like a side content or something that we want to highlight, like featured products or featured content. We can then tune the search further by specifying weighted search fields. So if there's a specific field in your content that should have more weight than other fields, if a keyword exists, that would then give it a significant boost in the ordering of the results, depending on what the weighting is you've put on those certain fields. And then another thing we can do is we have a mini list thing we can use for additional content. So, for example, if you're on a news page and you wish to look at related news, or you'd like to recommend other products that are related to the product someone is looking at, we can just sort of render them out with what we call an inline mini list. And then another thing that we can look to do is implement a live search box. So this is sort of giving you search suggestions as you type, or essentially search as you type. So we would look to implement that with a mini list that's taking the input from our search input box and then running it through one of our configurations that we've set up to search over the right content to return those live results. And then that brings us on to, what about if your data isn't in Contensis? The demonstration that we show today is showing all Contensis data, and it's all based in entries, and it's all fetched using the delivery API. But don't worry, there are still options, and we have lots of clients that do have a search with us that their data isn't entirely in Contensis, or some of it is in Contensis, but others, parts of their estate, are distributed in other sites, which is not uncommon. But we can actually feed Contensis with some search metadata using a number of approaches that we've done in the past. So you can do a bespoke import to import some metadata from a back-end system to signify the existence of the content, and just so that we can basically include it in the search. We can spider and crawl external websites as well, and bring some of that entry data into Contensis so we can leverage Elastic. But there's also one more option, which is a lesser known feature. It's kind of a hidden feature in the search package, is that you can actually use a custom API to fetch results for the search, and with the help of the mappers we can then translate those wildly varying results into a normal set of standard props that our application can use. So after seeing the live demonstration and the sort of benefits that we've hopefully got across to you today, in the sense that it's simpler, your configuration is visible, it's brought to the forefront, the approach should be consistent across the board, we should hopefully spend less time debugging, we get better support, we can turn things around quicker, we can give our projects better value. So with all of that, really, I think I'm going to now hand back to Emma, as that is the end of the demonstration.